Hello there, Cardinals. It's me, Mr. Ernst, and today we're going to be talking about how to find the square roots of something called a non-perfect square. So, as a review from last time, remember we're finding the square root of 16. This is a radical. This is the square root of 16. And essentially we're asking ourselves what number multiplied by itself is going to give me 16. And the answer to that would be 4. 4 would be the square root of 16. Coming over to this side, the square root of 25, again, this comes out to a nice even 5. But now we find ourselves in kind of a pickle here. The square root of 20, this is kind of tricky because if we look at, for example, well, we know 4 times 4 is 16, 5 times 5 is 25, but what about a number in the middle? So this makes it a little bit tricky because now we got to consider a number in between these two. This and this are considered perfect squares. We'll talk about that more in just a moment, but this is us going to be trying to find the square root of 20. So I'm going to get rid of this one here, and I'm going to get rid of this one here. And again, the easiest way to do this, what I highly recommend for anyone trying to find the square root of imperfect squares, to use something called a number line. Everything down on the bottom of my number line, all the numbers that are kind of already written in here, are going to be my roots. These are all of my square roots, okay? On the top side, everything on the top here is going to be my squared number, all of my perfect squares. These are perfect squares. Perfect squares. 1 times 1 is 1, so 1 squared is 1. 2 squared, 2 times 2 is going to give me 4. 3 squared, or 3 times 3, gives me 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is going to be 64. 9 squared will be 81. And then finally, 10 squared will be 100. And we're going to use this number line to find some of these imperfect squares. I'm going to put a couple more examples up here. Square root of 65 is equal to, and then we'll have also another imperfect square of the square root of, let's do 2, is equal to. Now, again, you might be able to use a calculator to find these, but this is basically talking about how you figure this out if you don't have a calculator. So, all right. So again, these are all of our perfect squares because they come from straight, even numbers. They're integers. They're not decimals. 4 times 4 gives me 16, so 16 is a nice square number. So now what we're going to be looking at here is finding the square root of, we're going to start off with 20. That was our first one. So 20. Here are all of my perfect squares, and what we need to look at is where does 20 fit in between all of my perfect squares? And the 20, if we're looking at this, is going to fall between the 16 and the 25. So the 20 somewhere is going to land here, which means the root of 20 is going to be somewhere between the numbers of 4 and 5. Now 20 is pretty evenly between these, so a safe bet for this is probably 4.5. So notice this is a non-perfect square, so we are going to get a rough decimal answer here. 20 lands in between these two, which means we're going to have roughly 4.5. So the square root of 20 is roughly, it's about 4.5, we're estimating. Next one, square root of 2. Again, we're looking at where all the perfect squares are. Where does the non-perfect square of 2 fall in? 2 is going to be right around here. Our value of 2 falls right here-ish. So this one's actually going to be a little bit closer to 1, so it's not going to be 1.5. This is probably going to be closer to 1 point, maybe 2-ish, or possibly even 1.3. So I'm going to say my estimate for this is 1.3 is my estimate. Notice again, the square root of a non-perfect square is going to give you some kind of decimal. The last one, the square root of 65, again, I can use my number line here. Looking at all of my perfect squares, 65 is going to fall just after this 8. It's going to be right here-ish. Again, this one's going to be much closer to 8, the 64, than it is to 81. So the square root of 65 is probably going to be 8.1. So the square root of 65 is probably 8.1. So again, use the perfect squares to find or estimate estimate your imperfect squares. You're not going to be able to know exactly what the square root of 65 is, but you can use the perfect squares to find a good estimate of it, okay? So again, the square root of 2, roughly 1.3. Square root of 20 is roughly 4.5. And the square root of 65 is roughly 8.1. That is how we find the square roots of non-perfect squares. Thanks for watching.